Okay, so we're going to start today. We're going to pick up at molarity. So when we go to make a solution, we would use this piece of equipment. Can somebody tell me what it's called? Starts with a V. No, nobody knows what it's called?
I think Kidder knows.
It is called a volumetric flask.
I do that.
Volumetric flask. This flask, they have certain quantities that they can you can make. So this is a 2-liter one. This one over here is 1 liter. We have a 0.5. Here is a 0.25. This would be 100. And this one would be a 50, 0.050 liter. They have little marks right here. And that is exactly that volume to that mark where you would read the meniscus. Okay. So molarity. Somebody remind me, what is the formula for molarity? Moles over liters. And that is liters of solution. So of the total. You will see me write it big M. I may write it as moles per liter. And you may also see me write it as moles liter -1. I'll write it all 3 ways. Doesn't matter which way is written. Okay, so here it says calculate the molarity of a solution containing 0.875 moles of sodium chloride in 1 liter. It wants it in 500 mils, 100 mils, and 6 liters. So we'll just start with the first one. So M is moles per liter. We have 0.0875 moles. Oh, sorry, thank you. 0.875 moles, and that is in 1 liter. So my molarity would be 0.875 big M. If we do it for 500, we're going to have 0.875 over, that's moles, over 0.500 liters. And what do y'all get? 1.75 big M. The next one says 0.875 moles per 0.1 liter, and we should get 8.75 big M. And the last one says 0.875 moles in 6 liters. And this time we get 0.146 moles per liter. Any questions on how to calculate molarity? Of course. There's always ways for it to get harder. So, how would you prepare how would you prepare 500 milliliters of a 0.05 molar solution of copper 2 nitrate? So I want you to tell me how you're going to prepare this. So where do we need to start? First of all, it's a solid. We're starting with a solid. So where will we need to start? What's the first thing we need to do to prepare this? How much do you need?
So you could do like 0.05 equals x over 0.5.
Okay. So we know, so M equals moles per liter, and you said 0.05 molar, and we don't know how much, but we need 0.5 liters. So how many moles do we need? So we need 0.025 moles of copper 2 nitrate. All right, I'm going to go back there, and it's not going to tell me in moles. When I get my little bottles of my powder, it doesn't come in moles. It's going to tell, I need to convert these moles to what? Grams. So 0.025 moles of copper 2 nitrate, and we're going to multiply that by, for every 1 mole, what's the molar mass of copper 2 nitrate? What'd you get?
I got 187.
That's what I got, 187.57 grams. So tell me, how many grams do we need? $4.69? Is that what you got, Kidron? Okay. 4.69 grams of copper 2 nitrate. All right, so we know we need 4.69 grams of copper 2 nitrate. So the first thing we need to do is we need to mass. So use technical terms, mass out. 4.69 grams and we're going to add it to, what did I call those things a while ago? Those long things where we make solutions? Add it to the volumetric flask. What size volumetric flask should we use? We need 500 milliliters, so we need a 500 ml volumetric flask. And then what we're going to do is we're going to add water. We're going to add water. We're going to swirl it around to get it to dissolve, add some more water, swirl it around to get it to dissolve, keep on doing that. And then finally, once all of it has dissolved, we're going to take it and we're going to add water all the way up to our tick mark, the volume, the appropriate volume. So add water until you have 500 mLs of solution. All right, so you need to know, you need to mass it out. Then you need to have a volumetric flask. And then take it until you get to the 500 mils. Yes?
Okay, so does the volume of the solid affect the volume of the solid or liquid or gas being adding to a solution affect the size of that solution?
Yes. Because it's not going to be a full 500 milliliters of water.
Yeah.
So as we're adding that and as those particles spread apart, the water is going to spread. That's why you have to get it to dissolve and keep swirling as you dissolve and add in that water. Okay? All right, calculate the volume of, so we need the volume of a 0.5 molar copper 2 nitrate solution to prepare 250 mils of a 0.04 molar copper 2 nitrate solution. So what kind of problem is this? Dilution. And what is the equation for dilution? M1 V1 is equal to M2 V2. So we have our start and we have our final. So our start, we're starting with a 0.5 molar solution. We don't know how much we need. We need to get to a 0.400 molar solution. And we need 250 milliliters of that solution. So what is my initial, how much do I need of my 0.5 solution? What'd y'all get? 20 milliliters. 20 milliliters of copper 2 nitrate. So what we'll do is we'll take 20 milliliters of copper 2 nitrate and we'll put that into our volumetric flask, and then we will add water up to the line on the flask, on the 250 flask.
Wait a minute, shouldn't it be 200?
It says a 250.
No, but
No, because the decimal is actually 0.04.
oh, okay.
Oh, sorry. Why didn't y'all say something? 0.04. All right. Determine the molarity of the total ions in a solution prepared by dissolving 9.82 grams of copper 2 chloride in enough water to make up a 600 milliliter solution. What's the molarity of the chloride ions? So we need to find the molarity of the total ions and the molarity of the chloride ions. So what's our first step? So we had 9.82 grams of CuCl2, and we need to convert that to moles by using the molar mass of copper 2 chloride, and I got 134.55 grams per 1 mole. Okay, I'm just going to go ahead and step this across, keep stoiching it across. We are in moles, and we need to get to molarity. So we know that, what's the molarity we need? We need 0.6 solution. We have 0.6 liters of solution, and that's just going to be over 1. So what do y'all get to 2 sig figs? What's the molarity of copper chloride? 0.122 molar copper 2 chloride. That is for the total molarity. It wants to know, so that's one answer. What is the molarity of the chloride ions? So if we have 0.122 moles in 1 liter for the copper 2 chloride, and we know that we have, for every 1 mole of copper chloride, we have 2 moles of chlorine. How many chloride ions do we have? Chlorine ions. One 0.122 times 2 is 0.244 molar chloride ions.
If you got 0.243, would they take off for that?
No, they would not. They're going to give you a certain leeway in there.
Okay. Because I just put the number that I got from the original.
Yeah, I don't know what, they're going to do a percentage of how close you are to that. Are there any questions to that? That should all just be review from pre-AP. I hope it's review. All right, so now you guys, I'm going to give you your solubility rules. I am going to give you some nice cheesy ways to memorize these, or to remember them, not really memorize them. You can use them or not, but it's helpful because you won't have a chart like this. So what we're going to do is, first of all, is we have most alkali metal salts. Those are our group 1. Okay, group 1 salts. Yes.
Is cesium not soluble?
Huh?
Is cesium not soluble?
We just don't put it in there because it's just,
Too reactive?
yeah, too reactive, yes. So group 1 metal salts, so your alkali metals and ammonium, are soluble. Within that, I also group up nitrate and acetate. And these are when they are ions. Nitrate and acetate. Those are all soluble. I call those 4 things the Big Daddy rule. We just scratch those out. You're not really going to see those. So I call them the Big Daddy rule. Everybody wants to get with Big Daddy, and Big Daddy's going to make you soluble. Okay? So, alkali metals, NH4, nitrate, and acetate are your Big Daddies. So anytime you see somebody hooked up with them, they're going to be soluble. Okay, so then we get to group 2, rule number 2. Chlorine, bromine, and iodine are soluble except for when they are with silver, mercury, and lead. So chlorine, bromine, and iodine, what type of elements are they? They are the halogens. So they are the halogens. Okay, so how do we remember this? This is how I remember it. Hal, and that's for halogens. Hugs, Aggies, pretty badly. Hal hugs Aggies pretty badly. Hugs is mercury. Aggies is silver. and pretty badly is lead. So if Hal is hugging one of those three, then it is not soluble. Okay?
That was wrong, that was, ow.
Hal hugs Aggies pretty badly. So if you're a halogen and you are hugging an Aggie pretty badly, then you are not soluble. We're going to go ahead and cross out rule number 3 because that really isn't going to apply to us. Oops. Oh, crap. Oh, there we go. So cross out rule 3, and we're going to go to rule 5. SO4, 2 minus. What is that? SO4, 2 minus. That is sulfate. Okay, so sulfates are soluble except for these 6 exceptions. So we're going to call sulfate sul. So sul is a man. So sul can bag hags pretty badly in Sri Lanka and Argentina. So sul is soluble unless he is with calcium, barium, mercury, lead, strontium, or silver. And then rule number 6, all these other things that are there, they're insoluble. But remember, if they're with something with in rule number 1, if they're with a big daddy, then they always have to be soluble. So carbonate, if it's with sodium, it's with a big daddy, so it has to be soluble. So if you remember rule 1, the big daddy rule, and you remember the halogens and the sulfate, you should be fine. Any questions on those?
Yes.
Okay. Everybody good with this before I go to the next? All right. So I do have one thing to mention. Oops. I don't want to go there. We're going to do this real quick. But somebody tell me if you see something like this. CH3OH. What is that?
Sodium hydroxide. Something. No, I said something.
Something hydroxide. Okay, you would want to say it's something hydroxide. But are there any metals in that group? Is there any metals? So it's not a hydroxide. It's not a base. If you see something like this, hint, hint, I would write this down and know. If you see something like this and there's no metal in there, it's not a base. It is an alcohol. Okay? So it's not a something hydroxide. It's not a ethane group or a methane group hydroxide. It's an alcohol. All right, go back to your rules. Let's determine, are they soluble or insoluble? Silver nitrate, soluble or insoluble in water? Soluble. Why is it soluble? It's nitrate, Big Daddy. Sodium chloride. Soluble. We have an chloride, a halogen, but it is not with one of those ones. Hugging, what is it? Hugs Aggies pretty badly.
You also have an alkaline water.
What? Oh, yes, an alkali metal too. Lead to bromide. We are bromine, and lead is Pb. So this is a halogen, hugging Aggies pretty badly, and we have pretty badly here, so it is insoluble. Ammonium hydroxide. Soluble. Ammonium is a big daddy.
Can we write that as our proof on a test?
Big Daddy. Big Daddy.
It's a big day.
It's a big daddy. Barium sulfate. Insoluble. Okay, so calcium hydroxide is a weird one. So hydroxide, unless it's with a big daddy, it's insoluble. But if it's very dilute, and we get 100% solubility, then it'll be soluble. But if it's a strong concentration, then it would be insoluble. And we're going to get to that in the next unit.
So we don't need to know that.
Well, you need to know that, yeah. And lithium carbonate. Soluble. Lithium is a big daddy. Are there any questions over what we discussed so far?
Any questions?
Yeah.
Oh, you want to take it first? Well,
Andrew would like that.
it's already on homeroom, so it's not like it's switching it.
Okay, so I think that covers through what is on your homework. So I'm going to pass out your homework, and we are done for the day. You have plenty of time to do your homework.